like I said, if I told you a house has 12 bathrooms, what does that tell you about that house? It's a big house. What if I told you the house was 20,000 square feet?
It's huge.
It's a big house. So I don't want these to be too close. We'll talk more about that tonight. But conceptually, you can keep putting additional variables in here. But when I threw out, to you guys, give me some ideas. Somebody said location. And do you remember my smart aleck answer to you when you said location?
How many locations?
How much location does your house have? I said, location's a good idea, but that's not something, I can't tell you how many locations my house has. Similarly, we talked about school district. Being in the good school district or the bad school district might matter. But that's not really a quantitative, measurable thing. What type of siding? Beth brought up, does it have brick? That might be something that's interesting. But I'm not going to ask how many bricks are on your house. That's essentially this. So what we're going to talk about tonight before we go to the computer, what if we want to include an x variable? And remember, your x variables are your explainers. So what if we want to include an explainer that is not quantitative? Now, you got to go back to, Stats 1, the very beginning, the first chapter or second chapter of Stats 1. We talked about quantitative compared to qualitative data. What is the difference between quantitative and qualitative?
How much versus?
Well, it's essentially the root word. What is the root word of quantitative? Quantity. So a quantitative variable is measuring how much square footage does your house, how much setback does your house have, how many bathrooms does your house have. But we might want to include something that is not quantitative. In other words, it's qualitative. We can do that. To do this, we have to use what are called, and they go by a couple of different names. The most common name you will see for this is what is called a dummy variable. I think your book actually calls them qualitative variables. Some books will call them indicator variables. Dummy variables is really the most common term. Although, as Dr. Kim, my econometrics teacher in grad school, told us, that's a bad name because dummy variables are really smart. And that's what passed for humor in econometrics. So that tells you something about that class. Dummy variables are a way to include a variable that is not quantitative. It's qualitative. But we got to think about how we're going to do that. And in order to do this, basically we're going to have a B4 up here, basically. We're going to have a B4, say a B4 X4, or maybe X4 is our school district. This would be an example of what we're calling a dummy variable. This is an indicator, a qualitative variable. We're not measuring how many schools are in your district or how much district does your house have. We basically want to assign some sort of an indicator variable that will help measure the effective school district, but we can't do it in a quantitative way. And I'm going to show you, it's really pretty easy, but this is the basic idea. We're just adding an additional variable, but the type of variable that we're adding now is going to be different. So let me pull, don't you guys go to the computer yet. Let me show you, and then I'll turn you loose on this to play with it yourself. But if you were to, oh, there it goes. And I will try to turn off some light, so maybe, whoa, that's not the password. There we go. So let me open this data set that I was going to use. Course contents, data sets, all the way down the bottom. Let me open, I did some tinkering with the house prices data set. So this is different than the house price data set, a little bit different than the house price data set we were working with last time, but not too much. So, okay. Oh. I'm doing this, y'all go ahead and open Minitab. Just click the start button and start typing the word Minitab, and it will pop up. Y'all go ahead and log into Minitab because you have to do the login thing. And then after I show you this, I'm gonna turn you guys loose to do some of this on your own. So y'all go ahead and log in.
With, at home?
I did.
There we go. All right. So the idea here, let me try to make big. There we go. So I've got my data up here. I have my price, my square footage, my setback, my bathrooms, that number of letters variable we made up last time. But then I have a variable here or data on the school district that a house is in. But you notice up at the top of the column, Minitab has that label C6-T. That's an indicator that this is a text column. I mean, obviously it's text, it's not numbers. I can't put words in my regression model. So what a dummy variable is, and let me go ahead and insert here. Let me insert the column. There we go. So basically a dummy variable is going to be a yes-no variable. Do you have this characteristic or not? So for the school district, we have, in my simple example, we have two school districts, good and bad. So I'm going to create a dummy variable, and I like to give my dummy variables good names. So I could make my dummy variable be a yes-no for good school district, or I could make it be yes-no for bad school district. Which one do you want? How do you want to code this? Good school or bad school?
Good.
Good. All right. So if I create a variable here that I call good school, basically to make this a dummy variable, all I have to do, everywhere I see good, every house that's in the good school district, I give it a value of 1. If it's in the bad school district, I give it a value of 0. So if you have a small data set, you can kind of do this by hand, but I'm going to show you a trick. And again, after we open up the data set and you guys play with it, you can kind of do this on your own. But basically, the best way, especially if you have a big data set, if I've got a variable like what school district you are, I'm going to go over here to data and then go down to recode. Do I want to recode my data to numeric or to text?
To numeric.
I want to make it numeric. I want to recode it from text to number. So I would go to recode numeric. And it's pretty simple, but you kind of have to pay attention a little bit. Up top it says recode the values in the following columns. So which column do I want to recode? Good school. Not good school, that's where I want to put my variable. I want to recode the school variable, where it's got good and bad. So I want to recode the school variable where it says good and bad. The method I want to use, and I think this is always the method you're going to use, and I know it's hard to see, but the second option says recode a single value. Or I'm sorry, no, the first option is what I want. Recode individual values. I thought it was second. So pick the variable where your good, bad, the column where your words are, good, bad, whatever. Recode individual values, and then Minitab is going to bring up this little box that tells you how it's recoding. Well, right now, it's going to give all the bad houses a 1. What value do we want bad houses to have?
0.
0. So just click in there, delete that 1 or change that 1 to a 0. It's recoding all the good variables as 2. What do we want those to have? 1. So change the 0 on bad to 0, good to 1. Again, the last thing just says, where do you want this variable to be? I could have said put it at the end of the current worksheet, but I already created a column for it. So I'm going to say I want it in specified columns. And now, Sean, which column do I want the dummy variable in? I want the dummy variable to be in the good school variable. Again, I'm going to turn you guys loose on one of these and let you do it yourself. It'll make more sense then. But when I do that, well, it gave me my little summary table, and it basically told me I had 15 bad school district houses and 15 good school district houses. I want to go back to my worksheet. So you see now we have a variable called good school. And good school has ones for all the houses that are in the good school district. It has zeros for all the houses that are in the bad school district. So, now that, actually, let me do one more thing. I'm just gonna do this real quickly. But we could have called our dummy variable bad school if we had wanted to. And I'm gonna need to do that root coding for me. Except now I'm still recoding individual values in school, but now I'm gonna get bads 1 and goods zeros. And then I'm gonna put that variable in the bad school column. Anyway, you didn't need to follow all that. I just did the same thing I did for good school, but I did it for bad school. All right. So now I'm ready to do my regression with the dummy variable. So if I want to do a regression, where do I start?
Stat.
Stat. So I go to stat, then I go to regression, then I go to regression, then I fit regression model, just like we've been doing. Stat, regression, regression, fit regression model. What is our response in this question? What am I trying to predict?
Price.
The price. So response is still price. Whoops. Now I click down here, and don't worry about the fact that there's a box there that says categorical predictors. I don't like the way Minitab presents that, so we're always putting our x's in the continuous box. Even though these really are the dummy variable is categorical, it works better if you just put it in continuous. So I'm just going to do square footage and good school district, since that's the one you guys suggested first. But I'm not gonna worry about setback, bathrooms. I'm just gonna do the size of the house and the school district. Now I am gonna change my results to basic. Click OK, click OK. And Minitab gives me my usual output. So there's the regression equation. So as always, let's talk through it. There's a plus sign on square footage. So what does the plus sign indicate?
As your square footage goes up, the price goes up.
Bigger house, bigger price. How about the good school district? It also has a plus sign on it. So what does that indicate?
The higher the
Better school, better.
price.
Well, a
the
positive
higher the
association at
school.
least. The interpretation of that's gonna be a little weird. But let's think about that 222.2. All right, I feel the need to walk to the front of the room. Y'all know I'm real big on this interpret the coefficients thing. So, how do I interpret the 222.2 on square footage?
Already accounting for the square footage.
No, we haven't already accounted for square footage. This is the slope of square footage.
Already accounting for good schools.
Already accounting for what school district the house is in, or holding school district constant. Either way, we're already accounting for that other variable, the school district. Now,
Each extra square foot, the price goes up $223.
sounds good. So already accounting for what school district the house is in, or already accounting for if it's in the good school district, holding school district constant, you can say any of those, but already factoring in the effect of good school. Each additional square foot raises the price $222.20. That's my estimate. Everybody okay with that? How do we interpret this? How would you interpret the 22,127 that's on good school? Well, you're gonna start the same way.
No, wouldn't you just swap it around?
Already accounting for square footage.
Okay,
for-
stop right there for a second. So already accounting for square footage or holding square footage constant, either way, square footage is already in the model. Now, what does the 22,127 tell me? Generally, we would say as school district goes up 1, price goes, but school district isn't quantitative. It's not a goes up 1 kind of thing, or goes up 2. So when it comes to interpreting dummy variables, that's a little bit different. It's still very similar. You still would say holding square footage constant, or already accounting for square footage, however you want to say that. But now when you come to interpret this number, you don't say as good school district, or as good school goes up 1. Instead, you would say already accounting for square footage, If the house is in the good school district, then the price is gonna be $22,127 higher. So it's no longer as this goes up, this price goes up, it's now a yes/no kind of thing.
Can you say that one
I
more time?
will. Already accounting for the size of the house, or holding the size of the house constant. If the house is in the good school district, if it has a 1, if it is in the good school district, it's gonna have a price that's gonna be $22,127 higher.
Can you say that a third time?
Already accounting for the size of the house, if the house is in the good school district, it's gonna cost $22,127 more.
More than,
That was my next question. $22,127 more than what?
bad school.
More than if it's got a 0 there. Now, which houses have a 0 there? The bad school district. So this $22,127 is your bonus for being in the good school district. Above and beyond the size of your house. Again, we're holding that constant. If the house is in the good school district, it's gonna have a price that's $22,127 higher compared to bad, the other category. That's always how you interpret dummy variables. It's holding everything else constant. If it is in this group, this is what happens to price, compared to the houses that aren't in that group. Yes, ma'am?
So if that was on a test, is there any good, like, little secret to know, okay, that's a dummy variable? It just says
Well,
good.
sure. I mean, the story would
Good,
tell
bad, it
you,
would
we
tell
collected data on houses, we've measured the square footage of houses, and we've also created a dummy variable to indicate if they are in the good school district. So yeah, I mean, you have to know what the variable is measuring to know it's a dummy. What if I told you we had a house that was 2,500 square feet and it was in the good school district? Could you predict the price of this house?
Yeah.
How would we do that? How big did I say it was? 2,500? So I would plug in 2,500 right here, multiply that times that. Did I say it was in the good school district? Yeah, so what would I plug in here? 1. So if it's in the good school district, again, you're going to add that to the price predicted by the square footage.
Okay. One more time.
You put in a 1 if it's in the good school district, and then it's just add.
You said 2,500 times the 22,2?
Well,
Yeah,
you
you
plug
plug
in
in
2,500 for square footage, and now it's just math. 2,500 times that, plus 22,127. If it is in the good school district, what will you plug in here? 1. So mathematically, what is that going to do? That's gonna add 22,127 to your predicted price. What if it was what if the same size house, 2,500 square feet, was in the bad school district?
Plus 0.
You would
I
just
still plug in
add the
2,500
33.
here, but what would I put in here?
0.
A 0. So what would happen to that 22,127 then?
Cancel
It would
out.
just go away, because 22,127 times 0, that part goes away. You only add that if it's got the 1, if it's in the good school district. Now, of course, you still need to add the intercept, but you know, it's still the same as before. You plug in the values, and then add. Well, plug in the values, multiply, and then add. The only difference is the only thing you're gonna be plugging in there is simply a 0 or a 1. Let's try, just to make sure, do this for the 2,500 square foot house in the good school district and see what you end up with.
Question, are we going to remove the 222.2, or are we going to multiply the 2,500 times that?
Well, you're gonna plug in 2,500 for square footage, and then what does that tell you to do? Mathematically, what does that equation tell you to
Well,
do?
what I mean, do we keep the 222 and then multiply that by the 2,500?
Well, mathematically, what does this say? 222.2
Was it in
times
the
square
good
feet,
district or
right?
bad district?
So you would plug in 2,500, and what would you do? Multiply times that,
Times
then add that, and then this, you're gonna add or not add, depending on whether it's in the good school district. So what did we end up with for the predicted price of this house?
580?
580?
$89.45.
All right, let's be a little more exact.
577,627.
577,627?
I got 589.45.
I got 5.
All right, let me go to my calculator.
So what do you do is you multiply that.
So
Yeah.
this says
222.
Where's that thing?
Actually,
589.45.
let me do this.
We didn't do
People
plus
are still asking
3,318.
about this. Let me do this real quick. Let me just send this to Word. Let me do it this way. So I've got this regression equation. 3318 plus 222 times square feet. Well, for this house, what is the square footage of the house?
2,500.
2,500. So I'm gonna plug in 2,500 for that. Then I'm gonna move over here, and I've got plus 22127 times good school district. So for this house, what value does it have?
1.
1, because it is in the good school district. So I'm just gonna plug in the square footage here. Then I'm gonna plug in a 1 because the house
Oh, yeah.
The house is in the good school district, and now I've just got a calculator problem. So I do 3318 plus 222.2 times 2,500 plus 22127 times 1, and I got $580,945.
That's what I had.
So $580,945. So y'all okay with that?
Yeah.
All right. What if, going back to my spreadsheet here, notice if you look back at the basic spreadsheet, we had two choices for the dummy variable. We could have used good school, we could have used bad school. I mean, there's no reason, there's no law that says the dummy variable has to be good. It could be, I want to see what effect being in the bad school district would have. Well, let me show you just real quickly. If we did that, stat, regression, I'm still going to do everything the same, except now I'm going to include, instead of good school, I'm going to include bad school. So I do this, and you might notice, I don't know if you would, well, actually, let me just copy it. Let me copy it and put it into Word here, make it easier to just see the two side by side. Has the intercept term changed? It has. The intercept term in our original equation was 3318. The intercept term now is 25,445. Has the slope on square foot changed?
Nope.
No. So that still tells me holding school district constant, already accounting for what school district the house is in, each additional square foot raises the price to 222.2, same as before. Notice the coefficient on our dummy variable. It's remarkably similar but different in a very important way. The amount, the magnitude of the coefficient is the same, 22,127. What's different though?
Negative.
It has a negative sign. How would I interpret that coefficient?
For being in the bad
Multiply it by
district,
0.
it's less
Now I want to
than-
interpret it.
Already accounting for square footage, the bad school would be negative
Reduce
22,000.
It's already accounting for the size of the house. If your house is in the bad school district, it's gonna have a price that's $22,127 lower compared to what? The good school district. The two coefficients tell me the same thing. If you put the good school in as your dummy, it's gonna say, oh, we need to add $22,000 to the price to reflect that you're in the good school district. If you put in bad school as your dummy, it's gonna say, oh, we need to subtract 22. It's the same magnitude, it's just one of them is gonna add to the price, one's gonna subtract. In fact, y'all may not believe me here, but take that same house that we predicted, 2,500 square feet, and which school district was it in?
The good one.
It was in the good school district. So what would I plug in here?
2,500.
2,500, that size of the house. Since it's in the good school district, what would I plug in here? Zero, right?
Mhm.
It's in the good school district, so it would get a 0 for bad school. So what would happen to that negative 22,000?
Cancels out.
Goes away. If it's in the good school district, it's gonna have a 0 here, that goes away. And somebody with calculator, you should be able to plug in this plus this times 2,500,
It's the 580,945.
and you get 580,945. The point of this example is to show you there is no right way or wrong way to do your dummy variable. You can make your dummy variable, I wanna see the effect of being in the good school district compared to the bad one. Or you could say, I'm feeling negative, I wanna see the effect of being in the bad school district. Either way, there's a $22,127 school district effect. Whether you add it to the price or subtract it from the price, depends on whether you're coding your dummy as good school or bad school. Could we put both of them in? Was that your question, Lisa?
I was gonna ask if you could have more than one dummy variable.
Well, we're gonna look at a situation like that. Yeah, you can. You can have lots of dummy variables. Could we put good school and bad school in the model?
I don't see
They
it.
just cancel each other out, wouldn't it?
Well, let's see what Minitab tells us when we do that. Let me point out to you, before I do this, Minitab is not a Southern software company. If they were from the South, they would give me a different message here. If I'm gonna run this regression, and I wanna put bad school and good school in there, and I tell Minitab to run this, it gives me a message up top. The following terms cannot be estimated and were removed. Good school. So what did it do? It basically ran my model, but it took good school out. If Minitab were a Southern company, that top little message up there would be, bless your heart, you didn't really mean to put both those in your model. You can't, if you've just got two categories, you can't have both of them in your model. And the reasoning behind that is pretty simple. If I tell you that house number 1 has a 1 in the good school variable, you already know what value it's gonna have in the bad school variable, right? What's it gonna have in the bad school? 0. House number 2 has a 0 in good school, so what's it gonna have in bad school? 1. You already know. Once you know the good school measurement for a house, you already know what the bad school is gonna be. Those two variables are telling you exactly the same thing, which school district the house is in. If you try to do that, Minitab's just gonna bless your heart and take one of them out. There's no reason to put both of them in there. Because once you've got one of them in your model, you don't need the other one. In fact, the other one can't be estimated even.
So if good school was a different predictor, would it still cancel it out? Like say if it was, like brick or something.
Okay, we're gonna look at, you could have multiple dummy variables. And in fact, I'm ready to turn you guys loose on this. So go to Blackboard, course content, data sets, and scroll down toward the very bottom, and you will find as soon as I make it available. I hid it because I didn't want you guys trying to do it while I was doing this. But as soon as I make it visible, you might have to hit refresh, sorry. But go to course content data sets and scroll down to the bottom here, and you will find a file, an item called House Prices Fall 2018. And there's two files attached there. You want to open the Minitab project file. So go down data sets to House Prices Fall 2018 and open that top file, House Prices Fall 2018.mpj. So we got it open? So you should have a data set that looks well, it doesn't have these two in there. Actually, let me get rid of bad school here. So the first thing I want you guys to do, I want you guys to create this dummy variable that I call good school.
Okay.
So go into Minitab, click on the data
Which data
button
set
up
is
top,
this?
Click on data, go down to recode, and recode to numeric. And I want you guys to create that dummy variable that we're calling good school. So when you do that, remember, it's gonna pop up a dialog box here. Which variable do I want to recode? School. So double click on school. And since we're doing good school, you want your good houses to have a 1 and your bad houses to have a 0. So just go in there and change bad to 0, good to 1. And since you haven't already created a column for this, I would say just at the end, tell it to put it at the end of your data set, the end of your worksheet, maybe. Or did I create the column in there for you?
You created, no.
No, so just put it at the end. Just say, put it at the end of my data worksheet. Now go back up to Window and go to HP Basic.
We typed in bad school?
Ma'am?
You just typed in bad school for the column?
No, you need to just choose the option, put it at the end of your worksheet, because you don't already have a column for it. So choose that option at the end of the current worksheet. And once you do that, it's going to create a 1-0 column for you at the end of your worksheet, and it's going to call it something like recoded school, something like that. Right?
Yeah.
Now I would, what I did is I went ahead and created my column first ahead of time. Again, if you get that session window pop up, click on Window at top and pick the HP Basic worksheet. So HP Basic should bring up a worksheet that looks like this. Well, yours won't have that in it. So let me get rid of that. There we go. So your worksheet should look something like this. Everybody get something that looks sort of like this? The first thing that I would do is I would retitle that recoded school column. So I would double click up in there and backspace, delete, however. I like to name my dummy variables what they are. Which houses got 1s in this column?
The
The
good
good ones. So I would name this column good school. Again, the reason I did that is I don't like having a variable that's just called recoded school. Because looking at the name of that variable, recoded school, I don't know if the 1s are good or bad. So I always like to title my dummy variables something related to the problem. So I got that? So do the same thing for the siding, but before you do that, go ahead and click in the top of column C9. And let's call that dummy variable, click in the top of C9 and call that one vinyl. Whoops. And go ahead and click in C10 and call that one brick. I didn't scroll down to show you this, but there's actually 3 different types of siding, vinyl, wood, and brick. And since we have 3 different dummy variables, or 3 different categories there, I can make 2 dummy variables if I wanted to. So go ahead and create the dummy variable for vinyl and create the dummy variable for brick. The only thing you're going to do differently is that at the end, you're not going to say just put this at the end. You're going to say put it in a specified column. And if it's the ones that you're giving vinyl's a value of 1, which column would you put that in? Vinyl. The ones that you put 1 beside brick, you're going to put that in the brick column. So do the same thing we did for school district, but you're going to see something different pop up. Go to data, recode, numeric. Go up here to data, back up at the top, data, recode, numeric. Now, which variable do we want to recode in this case?
Vinyl?
I don't have anything in vinyl yet. Which column of words do I want to recode?
Siding.
Siding. I wanna recode that siding variable and make it a dummy variable. So I'm gonna recode vinyl, so double click on vinyl. Now,
Wait a minute.
you didn't pick the right variable. We're not
He wants to
recoding
recode
school,
vinyl.
we're recoding vinyl. Oh, I'm sorry, we're recoding siding.
That works, siding,
Alright, hang on, watch me guys.
siding column, see?
We're still gonna go to data, recode, numeric. But now we don't wanna recode the school variable. Now we want to recode the siding variable. So double click on siding, and when you do that, it's gonna show me that I have 3 possible categories here: brick, vinyl, and wood. But which dummy variable am I trying to create right now?
Vinyl,
Vinyl. So I want all the houses that have vinyl to have a value of 1. How about the bricks?
0,
How about the woods?
0.
0. So you would change vinyl to 1, you would change brick and wood to 0. All the houses that are vinyl are gonna have 1s. All the houses that are not vinyl, brick or wood, will have 0s. And the only thing else you need to do, so bricks would get 0s, vinyls would get 1, woods would get 0. The only thing else I want to do is I want to put this in a specified column, but I'm not gonna put this in the bad school district column. Which column do I want this dummy variable in?
Vinyl.
The one called vinyl. So double click on vinyl. Well, I could do that. I guess it doesn't hurt. And it just tells me I had 10 vinyl houses. Go back to my basic worksheet, and it created a dummy variable for me for vinyl. Now, you guys do that for brick. I think y'all can do that. It's the same thing we just did, but we want to do the brick dummy instead of the vinyl dummy. Oh, I guess I should do that. So, data, recode numeric. I want to recode siding. Bricks are now going to get 1s. Vinyl and woods will get 0s. And I'm going to put this in the brick column. So when y'all do that, you should get a data set that looks, a worksheet that looks like this. You have a dummy variable for vinyl. Notice the first 10 houses in that column have 1s. How about all the rest of the houses in that column?
0.
They've all got 0s. They are not vinyl. That second dummy variable brick, the first 10 houses have 0s. The next 10 houses have 0s. The last 10 houses have 1s because the last 10 houses are brick houses. So any questions about creating the dummies? Beth and Eden, y'all got it or need some help? All right. So now that we've got these extra dummy variables created, I want you guys to run a regression, and let me write this down. I want you guys to run a regression where your y variable is price still. Your x variables are going to be square footage, good school, and let's say, actually, no, the first one I want you to run, I just want you to run price against square footage and vinyl. So that's the first regression I want you to do. Price will be your y variable, and your x variables are going to be square footage and vinyl. And this doesn't have freeze anymore as an option, so I'll wait till y'all get it done, then I'll do it real quickly. Sir? I would change my results to basic, just because it gets complicated if you don't. So So change results to basic, but outside of that, you don't need to mess with anything. Alright. So, price, square footage, vinyl. Let me check, make sure, yeah, it's still on basic. So when I ran my regression, I got this equation. Is that what y'all got?
Yep.
Alright. And by the way, at the end of tonight, you might wanna save this project and kinda email it to yourself or something. Just so you'll have it to go back and play with. So Minitab has given me a regression model, square footage and vinyl. So let's interpret. How do we interpret the 218.8?
Already accounted for vinyl.
So the siding on the house being held constant are already accounted for.
For each additional square footage, you add 218.8 on price.
Each additional square foot adds $218.80 to the house price, same as before. Now, this side of the room, because I think y'all have been kind of mooching off this side tonight, kinda. How would we interpret that negative 106 on vinyl?
The square footage is counted in.
Okay, so already factoring in the size of the house.
Size of the house, vinyl will, decrease the price
How
by
much?
106.
$106. Holding the size, or already, essentially, if you've got two houses that are the same size, that's what holding that constant means. You've got two houses that are the same size. If one of them has vinyl on it, it's gonna cost $106 less, basically. That's what that coefficient tells me. Could you predict the price of a 3,000 square foot house that has wood siding? You would plug in 3,000 for square feet. What would you plug in for vinyl if it has wood siding? 0. So again, that would go, that's only gonna get subtracted if it's a vinyl house. Wood and brick, that would go away because you're plugging in zeros for that. Okay? All right, now some other general questions. What's the R squared of this model? 90.3? So what does that mean?
90% of the price can be explained by square footage and.
I'm fine. I mean, basically, y'all are right. About 90% of the variation in house prices can be explained by variation in the size of the house and whether or not they have vinyl siding. All right. One final thing, actually two final things. I got to scroll up. Yes, John.
Question back to the square foot, and so it's, like, could I say holding square foot constant for every house with vinyl siding, the price is $106 lower than brick houses, or can I say the
All right.
price is lower by 100?
Hang on, let me say a couple of things related to Sean's interpretation there. When you're talking about dummy variables, we no longer say for every vinyl or for every whatever. You change your interpretation to if the house has vinyl. So holding square footage constant or already accounting for square footage, if a house has vinyl, the price of the house will be $106 less than, but this is a good question, and I didn't think to point this out to you guys. The price of the house will be $106 less than what?
Compared to the other?
If it had wood or brick.
Wood or brick, right? The houses that have zeros beside it. So that -106 is the effect of vinyl compared to wood or brick. Because wood and brick both had zeros. The interpretation of the dummy is always compared to which ones have zeros, basically. So this 106 penalty for vinyl is compared to wood or brick. All right. So, I'm sorry, Nate, did you have a question?
Yes, I don't know why I cannot get the good school
All right.
where I get it wrong.
Okay, you don't have a column called good schools. So change this option to just put it at the end of the current worksheet. Yeah. Now click OK. and go back
I'll
to,
go to your window.
and so now he's changed the name of that to Gazoo. Alright, okay, so final thing I wanna kinda walk through with you guys here. Remember last class, we were talking about how once you get to multiple X variables, there are two different sets of tests you can do. First, we have our overall ANOVA, our overall F test. And I can't reach up there to that, but the overall F test, remember, is testing whether anything in your model is significant. Is there any variable in the model that's significant? And what do I want to see in that top table that indicates that something is significant? Low p-values, right? The p-value for our overall F is what? 0.000. So what does that tell me? At least something in this model is significant. That's kind of my first step. I have to look at the overall model. Then, if the overall model tells me, yeah, something is significant, now I can go down here and ask about the individual coefficients. So yeah, something in the model is significant. But when I look down here at the coefficients table, square footage, is it significant? Yes. How do you know that?
P is low.
Because the p-value for square footage, assuming we're using 0.05, that is less than 0.05. So square footage is significant. How about the effect of vinyl? Vinyl turns out to be not significant here, and that's not surprising, I think. How much was the vinyl penalty?